Lesson 51.
Well, you don't see a number.
Page number 221. Imaginary numbers, products of square root theorem, Euler's notation, and complex numbers. So, like I said before, all numbers are ideas, and all numbers are imaginary. When I put a number on the board, that's just a symbol representing a certain quantity or a certain idea. It's not, the number 5 is not actually 5. It just represents a quantity of how many fingers? Well, how many digits? Okay. So, what we're going to do here is look at a couple situations. Square root of 3 times the square root of 2 is? Square root of 6, because you just multiplied what's on the inside, putting the radical sign on there.
Yeah, smart.
Square root of 3 times the square root of negative 2.
Oh.
Negative 6. Square root of negative 6.
Square root of negative I.
Square root of negative 6, guys.
No, you can't keep the negative square root.
Square root of negative 3. Square root of negative 2 is going to be negative square root of 6. Okay, some things you just have to remember. Okay, if both radicans are negative, we use a different rule called the product of square roots theorem, which if you want to look at that for your own enjoyment, it's the bottom of page 222, where it says if m and n, if those two numbers are both negative and they're both real numbers, then the square root times the square root equals, multiply them together to pull the negative out. All right, anybody know what a real number is? Define that for me. What is it? Yeah, that's really the best definition out there. Is a real number is a number on the number line. Which means that you can actually, you've got a number line going from 0 to infinity, negative to positive. I had to do it backwards. Going okay, which is negative? Exactly the opposite. Okay, so negative to positive. If you could put it on the number line, it's a real number. If you can't put it on the number line, it's an imaginary number.
So a decimal.
Decimal, we can put that on there, right? Like 1.5 is between 1 and 2, so it can go on the number line, so it's real. But the square root of negative 4 is not a real number because you've got to find a number so that when you square it, you're going to get negative 4. Well, what happens every time you square a number? It becomes positive. So that means there is no number that exists that you can square that is going to give you a negative 4. And that's where we run into imaginary numbers. Now, my friend, Mr. Euler, which some of you that are not mathematicians would pronounce Euler. You got that award? You better know how to pronounce it then, right? Okay, so our Swiss mathematician, Euler, he's the one that came up with the letter I for
Is that why you put
symbols.
an I in this thing?
What?
Did you notice that? You put like the imaginary eye.
There.
I thought that was.
But did you notice it?
Oh, was that what it so was?
It would have, wouldn't it? What y represents is the square root of negative 1.
It's a backwards J.
So that's what my I represents. The square root of negative 1. In fact, you may even want to, on your pages, not with this, but write somewhere else, just to remind you of what that is. Whenever you see the letter I, it stands for the square root of negative 1. So, let's say that that's true. I squared would be the square root of negative 1 times Okay? When you take the square root of a number times the square root of a number, we get the square root of -1 squared, right?
No.
Letting this sink in, Elias. What if this was a 2 and this is a 2? Wouldn't that equal 2 squared?
Yes.
Same thing here. Okay? Any number squared that you're taking the square root of equals what?
1. That number.
Equals that. If I have the square root of x and I square it, it's just x, right? Because it undoes itself.
So instead of taking it out of the square root, we're just putting a square symbol on it.
Okay, so the square root of -1, that quantity squared, is equal to -1. What did I say over here I squared equals? -1. Okay? But you don't want to do all this work to get the answer.
No.
You just want to be able to look at this little table here. So let's say that I did something really evil,
Don't do it.
And so we had to.
and I said, what is the square root, what is I cubed equal to? We don't have the table there, let's pretend. That equals square root of -1, square root of -1, square root of -1. What is the square root of -1 times the square root of -1? -1 times the square root of -1. What is the square root of -1? I just had this up here on the board. What equals the square root of -1?
1.
I.
Did you say I or
I.
So this equals -I, right?
in one of the variables?
So I cubed is -I. So you can follow this format with everything. Let's say that I want to know what I to the 27th power is.
Oh my gosh. I hate you.
You're sick.
Find it yourself.
So the square root of -1 times the square root of -1. How many times?
27.
Okay, that'd be a real pain in the neck, right?
Yes,
Pain in
it
the
would.
All right, so here's the secret.
Calculator, Jay.
No.
No?
Well, good luck with the calculator finding imaginary numbers that don't exist on a calculator.
Calculator.
You should be getting error.
Do you have an imaginary calculator?
Imaginary calculator? Yeah, do right here. Tell me what you want. I to the 27th power would be
He probably knows.
-I.
Why? Oh, because 27.
Oh, it's odd. It's an odd number. Is that it?
I to the first power is odd too, and it's I.
It's because it's divisible by
And what
3.
about I to the 25th? I to the 25th is just I.
It's divisible by 3.
Okay, so here's the secret.
Or the cube of the.
All you have to do is take your exponent, divide it by 4. 27 divided by 4. 27 divided by 4.
6.
6, thank you. With how many left over? 3 left over. Because, golly, this is going to be real hard to teach if I don't even have my multiplication tables done. 27 divided by 4 is 6 with 3 left over. All I care about is the remainder. Because what this equals is the same as what my remainder is.
Oh.
Why is it 4?
It's always divided by 4?
Always divided by 4.
Whatever your remainder is,
Also, the
that's the
remainder
one.
is that number.
So if I have I
I cubed is -I.
I to the 13th power is going to be,
I to the first.
which is I, according to the table
But
over
what
there.
if you don't get an I4, I3, I2, I1, I0?
That's weird.
You will, always.
You don't.
What would you get?
5.
You can't get 5 because then you didn't take 4 into it enough if there's 5 left over.
Get 0.
You get I. So you couldn't get 1 then either, could you? You couldn't
Yeah, I
get
just
4.
did I to the 13.
But I mean, you couldn't get 4.
You divide it by 4
No.
and then
So you do why do you
Why
do
would we have an I 4 then?
you have 1 remaining.
Yeah, if you have one remainder, then it's.
Just I.
There.
That's why.
There's where the 4 came from.
Square root of -1.
We've got 1, 2, 3, 4. So if I have I to the 30 second power,
It would just be 1.
it would be 1.
Wait, just 1?
Because 32, 4 goes into 32 8 times with 0 left over.
Whoa.
Okay, so you can do that with, I mean, I to the 246th power, you can figure it out real easy.
So how would we get to a negative ones if it was 2? We wouldn't do that.
Yeah, I to the 14th power. 4 goes into 14 3 times with 2 left over, so it'd be -1. Okay, so that was free information there for you.
This is confusing. Oh, I just love eyes.
Okay, so, oh, you'll come to really enjoy eyes. We don't use eyes in calculus, so you only have a few years to deal with.
Enjoy them?
we use a lot weirder stuff than eyes in calculus. All right, so if I'm asking you for the square root of -13, this is actually the square root of 13 times the square root of -1, correct? Because 13 times -1 is -13.
Which is the same as the square root
What
of
is-
13 times I.
What is the square root of -1?
I.
Did you hear that? I caught that.
Yes, I did hear
before you
that.
even-
That's because you're just so smart.
So good.
That's what she does to do.
Okay. Square root of -4 equals
4
Square
times
root
-1
of 4
or
is
I.
square root of
Square root of
-1.
-1. Square root of
And that equals
Two.
square root of 4 and I.
what, Erica?
-4.
What? I got 2 I.
There we go.
2I.
Yay!
2i.
Look, I had it.
How do we know these?
So what you're going to
How does
do,
everyone know?
you're going to take the square root of the number and tag an I on it if there is a square root sign and a negative in there. So if I have the square root of -16, you're going to take the square root of 16, and this is an I. Square root of -12 is 2. Square root of 3, negative sign means there's an I on it. All that I does is replaces the square root of -1.
Negative.
We're gonna have to do these in our-
So you're saying the square root of -1 is imaginary?
What's that?
The square root of -1 is imaginary.
Yes. You can't graph it on a number line. All right, so can I erase that? There is a standard form of doing imaginary numbers. The standard form looks like this. A plus BI. So when you write an answer that has an imaginary number as part of it and a real number as part of it, the real number goes first, the imaginary number goes last. Okay? So, for example, if I have 4 plus 5i, that's how I want it written. I do not want it written like that. That is evil. Okay? It's
What
wrong.
if you do I 5 plus 4?
Yeah,
Write a smile.
those are horns.
I couldn't tell.
I know, I'm not very good. They look like red bananas.
We are
doesn't
a
it?
Christian school. We don't talk of the devil.
Okay, so real number, imaginary number. Okay, so I'm going to give you a really, really hard one here.
Is that evil?
Okay, the way that you add and subtract real and imaginary,
Kinda like-
is you.
I already know the answer.
You add the real, add the imaginary, and you be done.
Wow.
Thought this was gonna be.
You're done.
Wouldn't that be two?
Oh my gosh. It would be
One.
2.
Wait a
You mean
second.
two?
Oops.
Everyone's
Golly.
like, what?
I had to make it a little more difficult.
All you do is add them. Negative one.
You missed
Or you can still watch
the
this monster.
imaginary
Yeah.
negative one.
Yeah.
That's what I thought it said.
That you can add with numbers.
Okay, guys. Smart with me, I'll give you one.
This is so.
Yeah.
Laugh at me, will you?
Guys.
I'll show you.
Just be done, please be done.
All right, try that one. One last bit of information, and then we'll have 2 lessons done.
Oh, yay.
Okay. Give that one a shot. Okay, let's look at each I value one bit at a time. I cubed, according to our table, is what?
Negative I.
I squared is? What is I to the 5th?
It's not up there. Is that it?
Well, you divide 4 into it with 1 left over, so it's an I. So negative 3I, whoops,
Oh, that's what.
minus 2 plus 7I plus 4 plus 2I. Add my like terms together. And I get 9 minus 3 is 6I. And a negative 2 plus a 2, or 4 is 2. So,
Do you always put your number before your value with an I?
where were you?
Still got it wrong.
Sorry.
Remember?
Oh,
Yeah, remember that part?
Yeah.
Okay,
I
I
was
you
writing
caught up with the
something.
horn.
I was writing something
It was
else
like
down.
14.
I did that too.
That's what I was gonna do at first. I did that too, and then I divided it. I think